Okay, alright. That's what I'm looking for. Zoom in on that. Man, salamanders really are the coolest lizards. Wait, are salamanders even lizards?
Science!
Where is that coming from?
I can answer that question.
How did you get into my house?
Salamanders are actually not lizards.
Were you in the ceiling that entire time?
Although they do have the same body shape, salamanders are completely unrelated to lizards altogether. In fact,
Who are you?
What's up, nerds? Welcome to Nature Nerd 101, where we take brief looks into the science behind nature. Today, we'll be exploring how animals can be completely genetically unrelated, yet still similar in appearance. We'll use salamanders and lizards as our first example. When we look at the general body structure of a lizard and a salamander, it's pretty easy to forgive those who don't know the difference. However, when we start to understand lizards and salamanders further, we see just how drastically different they are. First, salamanders are amphibians and lizards are reptiles. That actually is about as far as we need to go to differentiate the two. But let's be honest, sometimes having a little extra knowledge pays for itself.
Hey man, you got the stuff?
Yeah, I got it right here.
Oh yeah, that's the stuff.
Huh. I guess salamanders aren't lizards. Now, in order to understand the difference between salamanders and lizards a little bit more, we need to break down the differences between reptiles and amphibians in a very basic sense. And I mean really basic. There are so many biological differences between reptiles and amphibians that we could probably sit here all day discussing them. So best to keep it simple. First, we'll start off by talking about amphibians, like the salamanders we had discussed earlier. Amphibians are a class of ectothermic, or what we used to refer to as cold-blooded vertebrates, that can be distinguished from other classes by having an aquatic larval stage that usually turns into a terrestrial adult stage. However, there are many instances in which amphibians spend the bulk or even the entirety of their lives within the water.
in fact, amphibians in general require a lot of water to keep their skin moist. It is their main source of respiration or breathing method. This is another fairly distinct feature between them and reptiles.
When are you going to leave my house?
Reptiles, like lizards, snakes, and turtles, for example, are a class of ectothermic vertebrates just like amphibians. But unlike amphibians, reptiles do not have a larval stage, and they typically have soft-shelled eggs that are laid on land rather than in the water like most amphibians.
Because reptiles have an external scaly protection, they're able to venture further from moist conditions, and they can often be found in direct sunlight because they require external heat sources to keep themselves warm.
Okay, now that we have a fundamental understanding of the differences between salamanders and lizards, I think we can concretely say that they're pretty obviously quite different from one another. However, even though they have virtually no relation to one another biologically speaking, why do they have such similar body structures?
Why are you asking me? I'm the one who accidentally summoned you here.
Oh, right. My bad. Well, the answer lies within a term known as convergent evolution. This term refers to when two unrelated organisms evolve in similar ways. Similar ecological or environmental pressures cause things to evolve in similar ways to overcome them. A better example of convergent evolution might be the fact that both birds and bats have evolved the ability to fly using wings. However, we know that feathers are the key to bird flight, whereas stretched skin forms the wings of bats.
If you're talking about bats, then why are you holding a golf club?
Hey, I'm a nerd, not an athlete. I don't know sports. Go long. Right, so to summarize, lizards and salamanders are fundamentally and phylogenetically different from one another, being reptiles and amphibians respectively.
Now we know that just because two animals look similar doesn't mean they're in fact genetically related. Much the same way that this dog skull looks very similar to this raccoon skull, but we do know in fact that they're not related. This could be because of different environmental factors like pressures or behaviors that cause them to develop similar anatomical structures.
This convergent evolution is the key to why so many animals look very similar to one another, but in reality are completely unrelated genetically speaking. This is also why species are constantly changing within the scientific world. As scientists begin to decode and understand genetics, we see through the veil of convergent evolution and beyond just phenotypic and physical traits. As our knowledge increases, our awareness of the relationships between species increases, and we make updates to our understanding.
Wow. You know, now that you've explained it all, it does make a lot of sense. I do have one more question though.
Sure, ask me anything.
When are you gonna leave my house?
Oh, just a couple more minutes. See you next time.